Hi everyone, welcome back to my channel. Today in this video, we are going to study about the consistent hashing. So consistent hashing is a way to distribute data across the servers. Basically think of it that there are going to be multiple servers and we have to figure out a way by which we can distribute the data among all these servers. And one more thing that we have to take care of, for example, let's say one of the servers dies, or if we add one more server, then how we can redistribute the data. So consistent hashing is one of the way by which we can do this redistribution easily in a most efficient way. Redis use it, Cassandra use it, DynamoDB use it, and Kafka use it, CDN uses it. It is one of the most asked algorithm. It is one of the most asked concept in the interview. So this is why you should know how consistent hashing actually work. So if you'll notice here that there is going to be one client, it will send a simple request to the server and server will send the request to the database. So it is pretty simple. The client will send the request to the server will send the request to the database. Now, what we want to do in this diagram, in the second diagram, that we want to scale. If we want to scale, what I did is that I made three different databases. Now the question comes, whenever the server sends the request to the database, in which database the entry will go. For example, we have one request ID. Let's say, for example, I take the request ID 123. This is a request ID. Basically, this can be the header ID or anything. If this is a request ID coming, and if we want to store it into the databases, which database we will store? Maybe in DB1, DB2, or in DB3. So to figure out this request will go to which database, use the concept of the hashing. So let's understand it. So here you will see that I made three databases, DB1, DB2, and DB3. I make one hash functions as well. So this is the request ID. For example, I get this after I put the request ID 123 here, I get the result of 723. So now what I will do is I will divide this 723 with the modulo of number of databases that we have. So currently we have three databases. So I divide 723 with 3, divide modulo 3, then I will get 2. So when I'm getting the 2, then I know that I'm going to put this value on the database 2. For example, I'm going to get this value 746. Then I'm going to put this value into, let's say I'm getting the final result equals to 3. Then I'm going to put this value into database 3. First of all, we will hash the value, and after that we will take the modulus with the number of database servers that are existing right now. So we have the 3 database servers, that's why we divided with the 3, and we get an answer in which request will go to which database to be saved. So now let's discuss what are the problem in this normal hashing. When what is going to happen when we add one more server. So here you will notice that I added this DB4. If I add this DB4, then you will notice that now the number of servers are going to be 4. The hash value is going to be again 723, but previously we were dividing everything with modulo 3, but now what is going to happen after we add DB4, now we are going to take the modulus with 4. So think of it, if we have to make a read operation, when we are going to make the read operation, in that scenario, what is going to happen? If we take the modulo with 723 mod 4, the answer that we are going to get 1. But previously, when we were saving it, we saved it in 2. So it was saved in DB2, but at the time of read, what we are going to get? We are going to get this DB3. That is an issue. The actual value is going to be saved in DB2, but we are looking in this value in DB3. So to solve this issue, we have to redistribute the data. Whenever we are going to add this DB4, actually, what is going to happen if we are using this normal hashing, we have to redistribute the data in all the databases. So when we have the 4 databases, we again start redistributing. So we'll divide again, we'll go to the DB2, we'll divide it, and we'll again redistribute it to in all the 4 databases so that our read can work properly. But that is a very big problem. So this is the first problem, that redistribution becomes very costly with normal hashing whenever we add one more database. Now, same issue, what is going to happen if, let's say, our database 3 die. If one of the database die, again the value of our modulus will change. Previously it was 3, now the value of the modulus will become 2. Again, there is going to be the issue of redistribution. We write it in basically database 2, and now let's say 723 lies in database 1. Again, we will not be able to make the proper read calls. then again we have to do a proper redistribution of the data with the help of any cron jobs or anything. We'll do this distribution. After that only we can make the proper read calls. If we are not going to make the proper redistribution, then our system will not work properly. This is the issue. Now we understand what are the issues with normal hashing. Now let's talk about the solution. So the solution is going to be the consistent hashing. In actual scenario, what we are going to do, we are going to let's say we are going to make a ring of 2 to the power 32 integers, and we are going to appoint the databases some integer. Let's say for example, in my case what I did it that I made a ring of 120, and let's say I appointed db1 as 0, db2 as 30, db4 as 60, and db3 as 90. Now what is going to happen? Again the same logic. Let's say the hash ID is, let's say if I make hash, zoom it. Again I make the hash, let's say for example whatever the request ID, and after that what is going to happen? After this hash, let's say I get the value, let's say 123, and after that I'm going to mod it with some value, let's say x value, and I'm going to get, let's say 20. If I got this value 20, then I'm going to save the value in the next database. For example, if I'm going to get 20, I'm going to save it into db2. If I'm going to get the 40, for example, if I get the 40, I'm going to save it into db4. If I get 40, if I get 70, I'm going to save it into db3. If I get, let's say 110, then I'm going to save it into the db1. We are moving in the clockwise direction, and we are going to save the value into the next db that exists. So this is known as the consistent hashing. And now let's see how it is solving the problem of normal hashing. So we discussed the two scenarios: whenever the database is adding and whenever one of the database dies. These are the two issues that consistent hashing, these are the two issues that consistent hashing has to solve. So this is the issue 1. Now what is going to happen, that we are going to add our database. So let's say if we want to add this database 5, we can add it anywhere in the ring. For example, I added it at the location of 110. So I'll just write it down here that I added it at 110. Now it is going to be pretty simple, that the values between 100 to 0 is going to be into the db1. Values between db and values between 90 to 110 will go to db5. And again all the values between here and here, let's say for example 0 to 30 will remain same. The values between 0 to 30 to 60 will remain same. The value between 60 to 90 will remain same. We will not make any single change. So that is why it is pretty easy that we want to add a database, we can just put it between any of the databases, and now the distribution will happen. Because we know the logic is that whichever is the next database, we'll have to send the value to that db. So this is how we can add a database into the ring. Now let's see what is going to happen if we want to delete a database. So delete a database means that one of the database is not working. Basically it expires or it crashes because of some reason. So in our case, let's say we are taking the example, let's say db2 dies for some reason. If db2 dies, so think of it, what is going to happen? Let's say there is a request at this point, as let's say at 15. Now what is going to happen? That request will reach to db4. That request, let's say at the request at let's say 35 will also reach to db4. So we will notice all the requests between 0 to 60 will start reaching to db4. So at this time db4 will have lot of load. Now because db4 will get like say 2x amount of load. This is a problem. Now we have to again solve it, and I told you that consistent hashing we can solve it. So this is the basic idea of the consistent hashing. Now I'll give you the final picture, how actually consistent hashing look, and when you will see it, you will understand it that this is not going to happen, and db4 will not going to get actually 2x amount of load. So let's see it. We will going to use the concept of virtual nodes in it. So this is the final solution with the virtual node. It is easy to understand what I did it. So this is the actual node db1, db2, db4 and db3. These are the actual nodes, and what I did it, I made some virtual nodes here. So this db3, db1, db2 and db4 are the virtual nodes. What is actually happening? For example, if I get a request between 0 to 10, this request will go to DB3. So DB3 means that this is the virtual node, but actually the value is going to save into this DB3. This is a virtual node. So this is just a pointer that is pointing that we have to store the value between the DB3. Now let's take one more example. For example, there is a value between 20 to 30. Now the value is between 20 to 30, it was going to save into the DB2. Now if there is a value between 30 to 40, again 30 to 40, the value is going to save to DB1. Now let's say if there is a value between, for example, 50 to 60, the value is going to save to the DB4. Now we are going to take the example if let's say DB2 dies. So if in this case DB2 dies, what is going to happen? The request between 20 to 40, instead of going to DB4, the 20 to 40 request will start going to DB1, because this DB1 exists here and it is pointing to DB1, and the request between 40 to 60 will going to DB4. The request between 0 to 10 is going to DB3. So all the load that we were previously thinking will go to the DB4, that doesn't happen. So this is how the concept of virtual nodes in the consistent hashing save and divide the load bit across the databases, and this is why the consistent hashing is used in multiple databases clusters. For example, we use it into Redis, Cassandra, DynamoDB. Consistent hashing used every single where. So this is the concept, and it is one of the most asked interview questions in the interview of system design. So this is it for the video. Thanks for watching me, and we'll meet into the next video, and bye bye.